Hey everyone, in this video I'm going to challenge myself to complete 24 questions in just 1 hour. So let's begin. So lipoproteins. So first question is about the classification of enzymes. We'll be discussing at the last, and the second question is about metabolism of low density lipoproteins LDL. Add a note on hypercholesterolemia. Lipoproteins are molecular complexes that consist of lipids and proteins. Lipoproteins consist of lipid and protein, though be conjugated proteins. They function as transport vehicles for lipids in blood plasma. They function as transport vehicles for lipids in blood plasma. They function as transport vehicles for lipids in blood plasma. Okay, to transport the lipid vehicles for lipids in blood plasma. They function as transport vehicles for lipids in blood plasma. So they function as transport vehicles for lipids. They transport the lipids in blood plasma. Lipoproteins deliver the lipid components, cholesterol, triglycerol, etc. to various tissues for utilization. Okay, they work as lipoproteins. They work as vehicles. And they transport cholesterol, triglycerols to various tissues for utilization. Okay, structure of lipoproteins. Lipoprotein basically consists of a neutral lipid core with triacylglycerol and or cholesterol ester is surrounded by a coat shell of phospholipids, apoprotein and cholesterol. The polar portions amphibilic of phospholipids and cholesterol are exposed on the surface of lipoprotein so that lipoprotein is soluble in aqueous solution. Structure of lipoproteins. A lipoprotein basically consists of a neutral lipid core. So there is a core, neutral lipid core with triacylglycerol and or cholesterol ester surrounded by a coat shell of phospholipids. They are surrounded by a coat shell of phospholipids, apoproteins and cholesterol. The polar portions amphiphilic of phospholipids and cholesterol are exposed on the surface of lipoprotein so that lipoprotein is soluble in aqueous solution. So what is lipoprotein? Lipoprotein are molecular complexes. They consist of lipids and proteins. So lipoprotein नाम से पता चला it consists of lipids and proteins. They are molecular complex. It is a complex that consists of lipid and protein. Nothing but conjugated protein. They function as a transport vehicles for transport of lipids in blood plasma. What they transport? Cholesterol, triacylglycerol to various tissues for utilization. Structure of lipoproteins. A lipoprotein basically consists of a neutral lipid core. The neutral lipid core consists of the triacylglycerol and cholesterol ester surrounded by a coat shell of phospholipids. So it is surrounded by a coat shell of phospholipids, apoproteins and cholesterol. So it is surrounded by a coat shell of phospholipids, apoproteins and cholesterol. So the core is surrounded by a coat. The core, neutral core, lipid core, the neutral lipid core is surrounded by a coat shell of phospholipids, apoprotein and cholesterol. The polar portion, that is amphibilic of phospholipids and cholesterols, are exposed on the surface of lipoprotein, but the lipoprotein is soluble in aqueous solution. The polar portion is amphiphilic of phospholipids and cholesterols are exposed on the surface of lipids so that the lipoprotein is soluble in aqueous solution. So what does it mean? Lipoproteins consist of, it is a molecular complex. It consists of protein and lipid. The lipoproteins are transport vehicles for the transport of lipids in the blood plasma. They transport cholesterol and triacylglycerols to tissues for the utilization. And structure of lipoprotein consists of a neutral lipid core with triacylglycerol or cholesterol ester or triacylglycerol. It is surrounded by a coat shell of apoprotein or phospholipids and cholesterol. The polar portion is amphiphilic of phospholipid and cholesterols are exposed on the surface of lipoprotein so that lipoprotein is soluble in aqueous solution. It is soluble in aqueous solution. The polar portion is amphiphilic and it is exposed on the surface. It is made up of phospholipids and cholesterol, and it is exposed on the surface of lipoprotein so that the lipoprotein is soluble in aqueous solution. Okay. Classification of lipoproteins. Chylomicrons, very low density lipoproteins, high density lipoproteins and free fatty acids with albumin. And apolipoproteins, metabolism is there. So what they are asking, metabolism of low density lipoprotein. At a note on hypercholesterolemia. Okay, disorders of plasma lipoprotein. Oh my god, how can I complete this much? Okay, classification. First, let's see the structure. A general structure of lipoprotein complex. For the sake of clarity, only a part of the shell and core are filled with the constituents. Okay, so this neutral core consists of the lipid core. It consists of triacylglycerol and cholesterol ester. and the shell coat, the outer it is surrounded the lipid core. The lipid core is neutral core is surrounded by the coat shell, and this shell consists of the phospholipids, apoprotein, and cholesterol. Phospholipid, apoprotein, and cholesterol. Okay, structure is done. Structure is sorted. Classification of lipoproteins. 5 major classes of lipoproteins are identified in human plasma. So 5 major classes of lipoproteins based on their separation by electrophoresis. Based on the separation by electrophoresis, chylomicrons, they are synthesized in the intestine and transport exogenous dietary triacylglycerol to various tissues. What is chylomicrons? Chylomicrons, they are synthesized in the intestine. Okay, they are synthesized in intestine and transport exogenous, means dietary triacylglycerol to various tissues. They consist of highest 99% quantity of lipid and lowest 1% concentration of protein. The chylomicrons are the least in density and the largest in size among the lipoproteins. Among the lipoproteins, they are the largest in size. Chylomicrons, they are synthesized in the intestine. They are the exogenous dietary triacylglycerol. They transport to various tissues, and they consist of highest 99% quantity of lipid and lowest 1% concentration of protein. The chylomicrons are the least in density and the largest in size among the lipoproteins. Density is less, largest in size among lipoproteins. So chylomicrons, they are synthesized in the liver, and they transport dietary exogenous, means exogenous triacylglycerol to various tissues. So chylomicrons, they transport dietary triacylglycerols to various tissues. They consist of 99% of lipids and 1% of proteins. The chylomicrons are least in density and largest in size among the lipoproteins. Very low density lipoproteins, VLDL, they are produced in liver and intestine. Produced in liver and intestine. LI. VLDL is produced in liver. V for liver and intestine, and are responsible for the transport of endogenously synthesized triacylglycerol. Chylomicrons exogenously synthesized triacylglycerol, and they are synthesized in the liver and in the intestine. Chylomicrons in the intestine, and VLDL in the liver and the intestine, and they endogenously synthesize the triacylglycerols. Low density lipoproteins, LDL, they are formed from VLDL in the blood circulation. So LDL are low density lipoproteins. LDL, they are formed from VLDL in the blood circulation. They transport cholesterol from liver to other tissues. So LDL, they are formed from VLDL in the blood circulation. They transport cholesterol from liver to other tissues. Okay, so VLDL, from VLDL only LDL is formed in the blood circulation. LDL, low density lipoproteins, they are formed from VLDL in blood circulation. They transport cholesterol from liver to other tissues. High density lipoproteins, HDL, they are mostly synthesized in the liver. Three different fractions of HDL, 1, 2, and 3, can be identified by ultracentrifugation. HDL particles transport cholesterol from peripheral tissues to liver, reverse cholesterol transport. So high density lipoproteins, HDL, they are mostly synthesized in liver. HDL, they are mostly synthesized in liver. HDL synthesized from liver. VLDL synthesized from both liver and intestine. LDL synthesized from VLDL in the blood circulation, and they transport cholesterol from liver to other tissues. Talking about HDL, they are synthesized mostly in the liver. Three different fractions of HDL, 1, 2, and 3, can be identified by ultracentrifugation. Three fractions are found. HDL particles transport cholesterol from peripheral tissues to liver. Means reverse cholesterol transport by HDL. Peripheral tissues to liver means free fatty acids, albumin. Free fatty acids in circulation are in a bound form to albumin. Free fatty acids in circulation, they are bound to the albumin. Each molecule of albumin can hold about 20 to 30 molecules of free fatty acids. The lipoprotein cannot be separated by electrophoresis. Lipoproteins, they cannot be separated by electrophoresis. Talking about apolipoproteins, or apoproteins. The protein components of lipoprotein are known as apolipoproteins or simply apoproteins. They perform the following functions. The protein components of lipoproteins are known as apolipoproteins or simply apoproteins. They perform the following functions. Act as the structural components of lipoproteins. Recognize the cell membrane surface receptors. Activate enzymes involved in lipoprotein metabolism. So what are apolipoproteins, apoproteins? The protein component of lipoproteins are known as apolipoproteins or simply apoproteins. They perform the following function. So the protein components of lipoproteins are known as apolipoproteins. The protein component of lipoprotein is called apolipoprotein or simply apoprotein. They perform the following function: act as structural component of lipoprotein. They act as structural component apoproteins or apolipoproteins. Structural component of lipoproteins. They recognize the cell membrane surface receptors. They recognize the receptors that are present in the cell membrane. Recognize the cell membrane surface receptors. Activate enzyme involved in lipoprotein. Activate enzyme involved in lipoprotein. Activate enzyme involved in lipoprotein. Activate enzyme involved in lipoprotein metabolism. Activate enzymes involved in lipoprotein metabolism. Apoproteins, they recognize the cell surface receptors present on the cell membrane. Cell membrane surface receptors. They activate enzymes involved in lipoprotein metabolism. They activate the enzymes involved in lipoprotein metabolism. The comparative characteristic feature of different lipoproteins with regard to electrophoretic patterns, size, composition, etc. So the comparative characteristic of different lipoproteins are regard to electrophoretic patterns, size, composition, etc. So talking about comparative characteristic feature, so the comparative characteristic feature of different lipoproteins with regard to electrophoretic pattern, size, composition, etc. Electrophoretic pattern, but they cannot be separated by electrophoresis. No, the comparative characteristic feature of different lipoproteins with regard to electrophoretic pattern, size, composition, etc. So here cathode negative and anode positive, origin at the cathode and mobility towards the anode. So chylomicrons are highly negatively charged. Then LDL, beta lipoprotein, VLDL, pre-beta lipoprotein, HDL. This lipoprotein cannot be separated by electrophoresis. The comparative characteristic feature of different lipoproteins with regard to electrophoretic pattern, size, composition, etc. Okay, chylomicrons, LDL, VLDL, HDL. HDL is more positive, it is present towards the anode. No. HDL is negative because it consists of large amount of protein, so that's why it's towards the anode. Whereas chylomicrons consist of large amount of triacylglycerol, which are positive. Proteins are negative now, that's why HDL consists of large amount of proteins, that's why it is towards the anode. So chylomicrons, they consist of largely of lipids, positive, so they are towards the cathode. So chylomicrons, LDL, then VLDL, then HDL. LDL consists of cholesterol and it is synthesized from the VLDL. Okay, let's talk about metabolism of lipoprotein. That's asked in the question. Metabolism of lipoproteins. A general view. A general picture of lipoprotein metabolism is depicted here. Okay, so chylomicrons are nascent and synthesized in the small intestine during the course of fat absorption. Metabolism of lipoproteins, a general view. What's the time after completing 1 hour? 1956. I started in 1940. It means oh my god, I'm gonna get 10 minutes done, 15 minutes done. So a general picture of lipoprotein metabolism. Chylomicrons are nascent and synthesized in the small intestine. Chylomicrons small intestine during the course of fat absorption. They contain apoprotein B48 and mostly triacylglycerols. They contain apoprotein B48 and mostly triacylglycerol. Apoprotein B48 name is given since the apoprotein contains 48% of protein coded by ApoB gene. Chylomicrons are produced when nascent particles combined with ApoC2 and ApoE derived from HDL. Okay, chylomicrons, they are synthesized in the small intestine during the course of fat absorption. They contain apoprotein B48. Chylomicrons, apoprotein B48 and mostly triacylglycerols. Apoprotein B48 name is given since the apoprotein contains 48% of protein coded by ApoB gene. Okay, chylomicrons is given since the apoprotein contains 48% of protein. That protein is coded by ApoB gene. Chylomicrons are produced when nascent particles combine with ApoC2. And ApoE derived from HDL. ApoC2 and ApoE derived from HDL. HDL, ApoC2 and ApoE are derived from HDL. The liver synthesizes nascent VLDL containing ApoB100, which are rich in triacylglycerol and cholesterol. The liver synthesizes nascent VLDL containing ApoB100, which are rich in triacylglycerol and cholesterol. Circulating HDL donates ApoC2 and ApoE to convert nascent VLDL to VLDL. Okay, so this is very important. Chylomicrons are nascent. They are synthesized. Chylomicrons are nascent. They are synthesized in small intestine during the course of fat absorption. They contain apoprotein B48 and mostly triacylglycerol. Apoprotein B48 name is given since this apoprotein contains 48% of protein coded by ApoB gene. So ApoB48, 48% of protein coded by ApoB gene. Chylomicrons are produced when nascent particles combine with ApoC2 and ApoE derived from HDL. ApoC2 and ApoE, they are derived from HDL. The liver synthesizes nascent VLDL containing ApoB100, which are rich in triacylglycerol. The liver synthesizes nascent VLDL containing ApoB100. Okay, liver synthesizes a nascent VLDL which contain ApoB100, which are rich in triacylglycerol and cholesterol. Circulating HDL donates ApoC2 and ApoE to convert a nascent VLDL to VLDL. So VLDL contains ApoB100 and chylomicrons contain ApoB48. So VLDL contain ApoB100, which are rich in triacylglycerol and cholesterol. Triacylglycerol and cholesterol, and chylomicrons contain only triacylglycerol. VLDL contains triacylglycerol and cholesterol. Circulating HDL donates ApoC2 and ApoE to convert nascent VLDL to VLDL. Role of lipoprotein lipase. The enzyme lipoprotein lipase is present in the capillary wall of adipose tissue. In adipose tissue, capillary walls of adipose tissue. Adipose tissue capillary walls consist of lipoprotein lipase, and also not only adipose tissue, cardiac and skeletal muscle capillary walls contain lipoprotein lipase. It hydrolyzes a portion of triacylglycerol present in chylomicrons and VLDL to liberate free fatty acids and glycerol. Lipoprotein lipase is activated by apoprotein ApoC2, and ApoE comes from the HDL. Uptake of chylomicron remnants by liver. Uptake of chylomicrons remnant as the triacylglycerol of chylomicrons and VLDL are degraded. So uptake of chylomicrons remnant by liver. As the triacylglycerols of chylomicrons and VLDL are degraded, they lose ApoC2. Okay, ApoC2, because lipoprotein lipase is activated by ApoC2. So after degradation of triacylglycerols, ApoC2 is lost, which is returned to HDL. The chylomicron remnants are taken up by the receptors present on the hepatocytes of liver. Okay, conversion of VLDL to LDL. So what happens is that the chylomicrons are nascent, and chylomicrons consist mostly of triacylglycerol and apoprotein B48. Apoprotein B48% of protein and synthesized by apoprotein is synthesized by protein synthesized by ApoB gene. Chylomicrons when nascent particles when chylomicrons combined with the ApoC2 and ApoE of HDL, they convert into chylomicrons. The nascent particles combined with ApoC2 and ApoE, they convert into chylomicrons. Liver synthesizes nascent VLDL. They contain mostly of triacylglycerol and cholesterol and ApoB100. Circulating HDL donates its ApoC2 and ApoE, and it converts into VLDL, and nascent VLDL converts into VLDL. So the capillary walls of the skeletal muscle, cardiac and adipose tissue capillary walls, they contain lipoprotein lipase, and it hydrolyzes a portion of triacylglycerol present in chylomicrons and VLDL to liberate free fatty acids and glycerol. Lipoprotein lipase is activated by apoprotein C2. The triacylglycerol present in the chylomicron and VLDL are converted into free fatty acids and glycerol by lipoprotein lipase, which is activated by ApoC2 of HDL. Then after that, ApoC2 is taken up by the HDL, and the VLDL and chylomicrons remnants are taken up by the receptors present on hepatocytes of liver. Conversion of VLDL to LDL. How VLDL is converted into LDL in blood circulation. So during the course of VLDL metabolism, intermediate density lipoprotein IDL is formed. During the course of VLDL metabolism, IDL is formed, which lose the ApoE and get converted to LDL. After losing ApoE, it converts into LDL. ApoE is returned to HDL. LDL contains high cholesterol, free and esterified, and less triacylglycerol. The conversion of VLDL to IDL and then to LDL is referred to as lipoprotein cascade pathway. So first VLDL converted to IDL, IDL converted to LDL. VLDL loses its ApoE to get converted to LDL, and this ApoE is returned to the HDL. HDL consists of ApoC2 and ApoE. So after that it will take the cholesterol ester transfer protein, CETP, cholesterol ester transfer protein, is synthesized in the liver. Liver synthesizes cholesterol ester transfer protein, cholesterol ester, cholesterol का ester वाला part transfer protein, and it facilitates the exchange of components between different lipoproteins. CETP can transfer cholesterol esters from HDL to VLDL or LDL in exchange for triglycerides. So what it is given, जो cholesterol ester transfer protein है ना, CETP, is synthesized in the liver and it facilitates the exchange of components between different lipoprotein. Okay, exchange of components CETP facilitates. CETP can transfer cholesterol esters from HDL to VLDL or LDL in exchange for triacylglycerol TG. So it's cholesterol ester transfer protein can transfer cholesterol esters from HDL to VLDL or LDL, HDL to VLDL or HDL to LDL in exchange for triglycerides. Cholesterol ester transfer protein, CETP. LDL receptors and supply of cholesterol to tissue. The most important function of LDL is to supply cholesterol to the extrahepatic tissue. Or the extrahepatic tissue is to supply cholesterol to extrahepatic tissue. The LDL particles bind to the specific receptor pits identified as glycoprotein on the cell membrane. The shape of the pit is stabilized by a protein called clathrin. ApoB100 is responsible for recognition of LDL receptor sites. So LDL receptors and supply of cholesterol to tissues. The most important function of LDL is to supply cholesterol to extrahepatic tissue. LDL work is to supply cholesterol to extrahepatic tissue. Cholesterol. It mostly consists of cholesterol. Because VLDL already given its triacylglyceride is degraded by lipoprotein lipase. The LDL particles bind to specific receptors. The LDL particle bind to specific receptor pits on the cell membrane. On the cell membrane, there are specific receptor pits identified as glycoproteins. So specific receptor pits called glycoproteins. So the shape of the pit is stabilized by a protein called clathrin. The pit shape is maintained by the stabilized by the clathrin. ApoB100 is responsible for recognition of LDL receptor sites. LDL receptor sites, ApoB100 is responsible for recognition, because we said apoprotein is responsible for the recognition of the receptor site. Deficiency of LDL receptor. A defect in LDL receptor results in elevation of plasma LDL. If there is a defect in LDL receptors are present on the cell membrane, plasma membrane of extrahepatic tissues. So if there is a defect in LDL receptors result in elevation of plasma LDL, hence plasma cholesterol increases if there is a defect in LDL receptors, result in elevation of LDL. However, plasma triacylglycerol concentration remain normal. Cholesterol levels are increased. Deficiency of LDL receptors is observed in type 2A hyper beta lipoproteinemia. This disorder is associated with a high risk of atherosclerosis, particularly of coronary artery. So it has asked about metabolism of LDL, and we are done with that metabolism of LDL. Talking about deficiency of LDL receptors. A defect in LDL receptor results in elevation of plasma LDL, hence plasma cholesterol level increases, whereas plasma triacylglycerol concentration remains normal. Deficiency of LDL receptors is observed in type 2 hyper beta lipoproteinemia, type 2A hyper beta lipoproteinemia. This disorder is associated with a high risk of atherosclerosis. So in metabolism of LDL, metabolism of lipoprotein, a general view. If we see again in the small intestine cholesterol, nascent chylomicrons are synthesized. Nascent chylomicrons consist of B48 and triacylglycerols. Then the HDL, the ApoC2 and ApoE derived from the HDL are taken up by the nascent chylomicrons, and it will convert into chylomicron by taking ApoC2 and ApoE. And now this mature chylomicron and the wall of the capillaries of adipose tissue, cardiac muscles, and the skeletal muscle. The lipoprotein lipase digests the triglycerol into fatty acid and glycerol, free fatty acids and glycerol. And then ApoC2 is taken up by the HDL, and the free fatty acids and glycerol. The free fatty acids are liberated in the extrahepatic tissue, and glycerol to the liver. Okay, now after this, the nascent VLDL, after taking the nascent VLDL, which is synthesized mainly in the liver, it takes ApoC2 and ApoE and converts into mature VLDL. This VLDL is digested by the lipoprotein lipase, and ApoC2 is taken from it, and then IDL is formed. Then IDL will lose its ApoE. And it will become LDL. Ideal after losing ApoE, it will become LDL. Ideal after losing ApoE, it will become LDL. So ideally it loses its ApoE and then it will become LDL, and then LDL is taken up by the liver. And this LDL is taken by the liver. Or it can be given into the extrahepatic tissue. The extrahepatic tissue, the LDL particles bind to the specific receptor pits. This receptor pit is known as the glycoproteins, and on the cell membrane, the shape of the pit is stabilized by clathrin. And this ApoB100 is responsible for recognition of LDL receptor site. ApoB100 is responsible for the recognition of the LDL receptor site, and a deficiency in that LDL receptor, elevation of plasma LDL, while cholesterol increases, triglycerol level concentration remain normal, and it is due to deficiency of LDL receptor type 2A hyperlipoproteinemia. And in this disorder, high risk of atherosclerosis, mainly coronary artery atherosclerosis, is seen. So like this it occurs. So what happens? The chylomicrons, the dietary triglycerol and cholesterol is absorbed by the chylomicrons. Mainly triglycerols are present in the nascent chylomicrons and consist of B48, ApoB48, apoprotein B48. B is because ApoB gene synthesizes this 48% of protein, and it consists of 48% of protein. And then after taking ApoC2 and ApoE from the HDL, it converts into chylomicrons, and this chylomicrons triglycerides are digested by the lipoprotein lipase, and the free fatty acids become extrahepatic tissue and glycerol back to liver. And VLDL, nasal VLDL, consists of triglycerol as well as cholesterol, and the B100, it consists of B100 apoprotein, and after taking ApoC2 and ApoE, it converts into VLDL, and after lipoprotein lipase, it will lose its ApoC2 back to HDL, and after losing ApoC2, it will become ideal, and ideal after losing ApoE, it will convert it to LDL, and LDL is taken by the liver or in the extrahepatic tissue. LDL levers the cholesterol. So this is all about metabolism of LDL, and now we'll be talking about hypercholesterolemia. Hypercholesterolemia. Yeah, that's what all about hypercholesterolemia. We talked about it, right? Hyperlipoproteinemia, and that plasma lipoprotein lipase deficiency, lipoproteinemia, and type 2B we have seen, hyperlipoproteinemia. Hyper. Okay, so we have done with it. Hypercholesterolemia is associated with atherosclerosis and coronary heart disease. Consumption of polyunsaturated fatty acids and fiber decreases cholesterol in circulation. Drugs such as lovastatin, cholestyramine, compactin, and clofibrate reduce plasma cholesterol. It has been proved that there is no significant correlation between dietary cholesterol and serum cholesterol. No significant risk. Okay, this consumption of cholesterol-rich foods, eggs, seafoods, etc., are now considered safe. Now, non-HDL cholesterol rather than LDL cholesterol is a better predictor of CVD and mortality. High LDL or HDL or high ApoB ApoA ratio indicates high risk of atherosclerosis. If there is high LDL and low HDL, then high risk of atherosclerosis. Hypercholesterolemia is associated with atherosclerosis and coronary heart disease. Atherosclerosis and coronary heart disease. Consumption of polyunsaturated fatty acids and fiber decreases cholesterol and circulation. Drugs such as cholestyramine, compactin, and clofibrate reduce plasma. Oh my god, it's 2013. Oh my god. Let's talk about homopolysaccharides, page number 10 and 21. So we have seen hypercholesterolemia because of I forgot what is hypercholesterolemia. It is associated with atherosclerosis and coronary heart disease. Consumption of polyunsaturated fatty acid and fiber decreases cholesterol and circulation. And drugs such as lovastatin and cholestyramine, compactin, and clofibrate reduce plasma cholesterol. So there is no difference between dietary cholesterol and serum cholesterol. So consumption of cholesterol with foods, extensive foods, etc. are now considered safe. Non-HDL cholesterol rather than LDL cholesterol is better predictor of non-HDL cholesterol, that is LDL, better predictor CVD and mortality. Okay, page number 12. So hypercholesterolemia, if you give fiber and polyunsaturated fatty acid, that will decrease serum cholesterol. Page number 10. Homopolysaccharides. Okay. Polysaccharides, in Greek, poly means many, are polymers of monosaccharide units with high molecular weight up to 1 million. So they are usually tasteless non-sugars and form colloids with water. So the polysaccharides are of two types: homopolysaccharides, heteropolysaccharides. Talking about homopolysaccharides. Okay, page number 21. So after talk about homopolysaccharides, what are homopolysaccharides? Polysaccharides or simply glycans consist of repeated units of monosaccharides or their derivatives held together by glycosidic bonds. They are primarily concerned with two important functions: structure and storage of energy. Structure of polysaccharides are linear as well as branch polymers are also seen. This is in contrast to structure of protein and nucleic acid, which are only linear polymers. Proteins and nucleic acids only linear, whereas polysaccharides are linear as well as branched. The occurrence of branches in polysaccharides is due to the fact that glycosidic linkages can be formed at any one of hydroxyl groups of a monosaccharide. Polysaccharides are of two types: homopolysaccharides and heteropolysaccharides. Homopolysaccharides on hydrolysis yield only a single type of monosaccharide. They are named based on the nature of the monosaccharide. Thus, glucans are polymers of glucose, whereas fructosans are polymers of fructose. Oh my god. Homopolysaccharides on hydrolysis yields only a single type of monosaccharide. So they are named based on their homopolysaccharides on hydrolysis yield only a single type of monosaccharide. So they are named based on the nature of the monosaccharide. Based on the nature of the monosaccharide, they are named what single type of monosaccharides. Homopolysaccharides on hydrolysis is only a single type of monosaccharide, so they are named based on the nature of the monosaccharide. The glucans are polymers of glucose and fructosans are polymers of fructose. Heteropolysaccharide on hydrolysis give a mixture of a few monosaccharides with the derivatives. Homopolysaccharides. Let's talk about homopolysaccharides. Starch. So starch is a carbohydrate reserve of plants, which is the most important dietary source of higher animals, including man. So source of starch is dietary source for higher animals. So carbohydrate reserve of plants. High content of starch is found in cereals, roots. So source, you can write cereal, roots, tubers, vegetables, etc. Vegetables, cereals, roots, tubers. Starch is a homopolymer composed of D-glucose units. D-glucose units are the dextrose. Held by alpha glycosidic bonds, it is known as glucosan or glucan. It has been 34 minutes. Oh my god. Glucosan or glucan. Starch consists of two polysaccharide components: water soluble amylose 15 to 20% and water insoluble amylopectin 80 to 85%. Chemically, amylose is a long unbranched chain with 200 to 1000 T glucose. It is held by alpha 1,4 glycosidic linkage. Okay, starch consists of two polysaccharide components: water soluble amylose 15 to 20% and water insoluble amylopectin 80 to 85%. Chemically, amylose is a long unbranched chain. Amylose unbranched, and it consists of 200 to 1000 T glucose held by alpha 1,4 glycoside because it is linear. Amylopectin is branched chain, alpha 1,6 glycosidic bonds at the branching point and alpha 1,4 linkage everywhere else. So amylopectin consists of both alpha 1,6 and alpha 1,4 linkages and this branched chain, whereas amylose is unbranched. Glycosidic bonds at the branching points and alpha 1,4 linkages everywhere else. Amylopectin molecule containing a few thousand glucose units looks like a branched tree, 20 to 30 glucose units per branch. Starches are hydrolyzed by amylase, pancreatic or salivary to liberate dextrins. So starches after hydrolysis by the amylase, pancreatic or salivary to liberate dextrins, and finally maltose and glucose units. Amylase acts specifically on alpha 1,4 glycosidic bonds. So starch is a carbohydrate reserve of plants, which is the most important dietary source for higher animals, including man. So a high content of starch is from cereals, roots, tubers like sweet potato, they are roots, right? Tubers, vegetables, etc. Starch is a homopolymer composed of D glucose units, and they are held by alpha glycosidic bonds, alpha and D. It is also known as glucosan or glucan because it is D-glucose. So starch consists of two polysaccharide components, water soluble amylose and a water insoluble because it is branched amylopectin. So amylose is 15 to 20% and amylopectin is 80 to 85%. Chemically, amylose is a long unbranched. It consists of alpha 1,4 glycosidic bonds, and the D-glucose units are held by alpha 1,4 glycosidic bond. Amylopectin, on the other hand, is a branch and consists of alpha 1,6 on the branching points, and normally it consists of 1,4 alpha linkages, glycosidic linkages. Amylopectin molecule containing only a few thousand glucose units looks like a branched tree, 20-30 glucose units per branch. Okay, starches are hydrolyzed by amylase. Pancreatic or salivary amylase, and it can liberate dextrins. And finally maltose and glucose units. Amylase acts specifically on alpha 1,4 glycosidic bonds. Talking about dextrin, so dextrin, dextran, inulin and insulin as a protein. Okay, inulin, glycogen, and cellulose and chitin. These are homopolysaccharides. Starch, dextrin, dextran, inulin, glycogen, cellulose, and chitin. Starch and cellulose from plants, glycogen and chitin animals. Okay, dextrin are the breakdown products of starch, as we have seen. Dextrins breakdown products of starch by the enzyme amylase or dilute acids. Starch is sequentially hydrolyzed through different dextrins, and finally to maltose and glucose. The various intermediates identified by iodine coloration are soluble starch blue, amylodextrin is violet, and erythrodextrin is red, and acrodextrin is no color. So the various intermediates identified are soluble starch blue is amylodextrin, starch is blue, amylodextrin is violet, and erythrodextrin red, and acrodextrin no color. So dextrins are the breakdown products of starch by the enzyme amylase or dilute acids. Starch is sequentially hydrolyzed through different dextrins, and finally maltose and glucose. The various intermediates identified by iodine coloration are soluble starch blue, starch is blue, and amylodextrin is violet. And no color. Okay, dextrin. Talking about dextrin.